Hello everyone. This is the fifth part of nodeMCU web server series of tutorials. In this part we will combine all previous information and build a very simple web page for nodeMCU to display data from AM2301 temperature and humidity sensor and to control state of onboard LED. Hardware setup is pretty simple. We only have AM2301 sensor, and for detailed instructions on connection and configuration, please watch part 4 of this series. Let's quickly summarize what we've done in previous tutorials. In first part we learned how to set up Wi-Fi connection and connect nodeMCU to our home network. We also learned how to configure web server object in order to access our nodeMCU board from browser. In part 2 I gave overview and explanation for very simple web user interface framework, few CSS classes and some HTML code, and how to integrate it into nodeMCU Sketch. When embedded into nodeMCU code, this allows us to display any data from nodeMCU in form of web page, and using buttons on the same page gives us means to send commands to nodeMCU. In third part, we have seen how to get current time and date from online NTP servers so we don't need real-time clock or RTC module attached to nodeMCU board. And in part 4, we learn how to connect very popular temperature and humidity sensor to nodeMCU and retrieve values from it. And now we will combine all that information and build simple web page which will show time, date, temperature, humidity, IP address and Wi-Fi network name. Also we will add a button with state indicator which will control onboard LED so we can switch it on or off using web page on our nodeMCU. For more detailed instructions about each segment, please go through these 4 previous videos. All links are in the description, as is linked to source code for this part. We saw HTML code for our web page in part 2 of this series. It's basically same as before, just without all the examples of framework components. Same as before, inside head element, we have style element, which holds our CSS classes for positioning and decorating all elements of our user interface. In body element of our HTML page, we have main div container, and this div holds all rows with information and buttons clients will see when they open root web page on nodeMCU. As you can see left in the browser, we have title row with text example. Then we have 6 information rows for time, date, IP address, wireless network name, temperature, and humidity values. Last row has a button for switching onboard LED on and off, and a simple color indicator to indicate if LED is on or off. As you can see in the code, we have our placeholders for real data provided by nodeMCU embedded in double hashtag symbols. In last row we have indicator div, which also has double hashtag placeholder for indicator CSS class, class on and class off, which will visually represent if onboard LED is on or off by changing background color to green or red. These placeholders will be replaced in nodeMCU code. And finally we set our href attribute of our switch link to /light toggle, which will trigger light toggle handle defined in nodeMCU Sketch. Now just convert this code at Tomeco Online text to C string converter for nodeMCU Sketch integration. This code should be very familiar for those who saw previous videos. For time we use EasyTime library, and for our sensor we use Dht library. First we configure Dht Sensor by declaring Dht object and feeding it with Dht type and Dht pin arguments. We also declare global float variables for storing temperature and humidity values and counter for tracking interval between reading from sensor. Then we define integer variable LED pin, which will hold pin number of onboard LED on nodeMCU. For nodeMCU, onboard LED is connected to D4 pin. Now we define bool variable LED state, which will hold the state of onboard LED. But here's the trick. Pins are active low on nodeMCU, which means that when you set them to low, then the circuit is closed, or in other words, light is on. It can be confusing, especially for Arduino coders, but when it comes to setting the pins, just use reverse logic. Low is high and high is low. Also note that my board works like this. I cannot say this for other boards with ESP8266. Next, we define time zone object and name it my local time. It will hold our local time zone and we will get current time and date using this object, which is part of EasyTime library. Then we have Wi-Fi configuration, IP configuration, web server declaration, and now we come to setup function. Below Wi-Fi configuration, we need to set operation mode of our LED pin. So we call pin mode function, pass it number of LED pin, and set it as output. We want to control this pin by turning it on and off. Under web server handles, we define handle for root web page and for light toggle function. In HTML, we defined href attribute of our switch link to call /light toggle handle. Now here we define this handle and direct it to call handle light toggle function, which is defined later in the code. At the end of a setup function, we set my local time zone object to match time zone we want to track time for. And finally, we call waitForSync function, which will synchronize EasyTime library with NTP online servers and start tracking time internally. In loop function, we have handle client method on server object, which listens to client web requests. Now comes counter increment and if block, which executes read sensor values function every 5 seconds and read values from sensor and then stores them in global variables. And lastly, we call digital write function, which will set LED pin to LED state value. When we declared LED state variable, we set it to false or low, and as this is active low board, this means we need to inverse LED state variable to get desired behavior. So in order to turn LED off, we need to write high to LED pin, and we do this by inverting real value of LED state variable. Same if we want to turn LED on, we need to write low. After loop function, we define our web server handles functions. Handle root function is called whenever client requests root web page on nodeMCU or simply just enters IP address of nodeMCU board into web browser. It will return to client whatever getDefaultPage function returns. GetDefaultPage function is defined later, and as you can see, it's of type string, so it will return string object, which will then be sent to client's web browser for rendering through this server send method. Handle light toggle is a little bit different. When client clicks on a button which is associated with this function, first it will inverse LED state variable. If it's true, now it will be changed to false, and vice versa. And now instead of sending page as handle root function does, we set redirect to root web page and execute it by calling send method on server object, but now with status of 302, which tells browser to redirect us to location set in send header method, which in this case is root of web page. We do it this way because when you click on a button to change LED state, it will request /light toggle URL. Without redirect, this URL will stay in address bar of your browser, and each time you refresh page, it will also execute LED state changing function. So to avoid unwanted behavior, we use redirect here. So when you click on button to change light state, it will redirect to root web page so you can refresh page without executing light toggle function again. This is handy if you set up automatic refresh on your web page or you manually refresh page after clicking on any button and sending commands to nodeMCU. And finally we come to getDefaultPage function. Here we declare page object of type string which will hold HTML web page we created. Before assigning value, you need to convert HTML code to C-friendly string. To do this, I use online converter at tomeco.net. Link is in the description. Just copy all HTML code, paste it into source text box, unselect split output into multiple lines, and hit convert. Now you have all HTML code in C-friendly format, and just copy it and paste into nodeMCU sketch. As HTML code holds our placeholders for real data, we call replace method on our string page object. We replace time, date, temperature, and humidity with real values. For IP address, we declare IP address type of object. As this is array, we need to construct string by combining each of elements representing numbers of IP address in human readable format. For network name, we just call SSID method on Wi-Fi object and it will return name of the network nodeMCU is currently connected to. Finally, we need to replace indicator light placeholder on our button. Depending on LED state, we set on or off value for this placeholder. It will just change background color of indicator to green or red to indicate if onboard light is turned on or off. And that's it. We return page object with replaced placeholders, and this string, which is actually HTML page, will be sent to client browser every time root web page on nodeMCU is requested. Last function is read sensor values, which reads values from our AM2301 sensor, checks if they are numeric, and stores new values to our global variables temperature and humidity. If you upload this sketch to nodeMCU and if all wireless information is correct, board should be connected to your home network and accessible on IP address you designated in Wi-Fi setup code. If you enter this IP address into your browser, you should get default web page with NTP, sensor and Wi-Fi information together with a button which controls onboard LED. If you click on the button, it will change state of onboard light and change indicator on left to match state of light. Red for light is off and green for light is on. With this simple framework with very small footprint and fully offline, you can get remote control feel for your projects. Best use case is with mobile devices, but can be used by any device with browser on the same network. You can easily customize CSS classes and HTML elements to match your needs to best suit your projects. Check links in description for all code and other videos in this series.